Okay, today is day one of distance learning. Every day on either the website or Google Drive, you will find a couple things. You'll find the PDF of the smartboard for the week with all the problems solved. You'll also find the bit.ly link for your assignments, and you'll find the video of the lessons for the week. So here's a warm-up for today's. I will scroll down to number 4 so that you can see the drawing and pause the tape and go ahead and work these problems through until you're ready to go on. Okay, number 1 on the warm-up, the sum of the degree measures of the complement and the supplement to a 16-degree angle. Well, this is a little bit different than what we've done before because it wants the sum of the complement and the supplement. Well, complementary angles add up to 90, so 16 plus some number will give us 90. Supplementary angles add up to 180, so 16 plus some number will give us 180. When we solve for each, we find the complement is 74 and the supplement is 164. However, neither of those is the answer because it wants the sum of those measures. So 74 plus 164 gives us the sum. Number 2, it says x plus 4 over 6 equals 4. Well, this equation we've seen plenty of times how to solve this. The first thing we have to resolve is the entire left side of the equation is being divided by 6. So we need to clear that out first by multiplying each side by 6. That allows the 6's to cancel out, and 4 times 6 is 24. So we have x plus 4 equals 24. Well, now we have a one-step equation. To get rid of a plus 4, we take 4 away from each side, getting 20 for x. Number 3. Robin had 40 apples to give to 3 groups of children. The first group ate 1/8 of the total apples, the second group ate 4 of the total apples, the third group ate 20% of the total apples. How many were left over? Well, when I see bullet points like this, I want to take them one at a time. So the first group ate 1/8 of the total. Well, there were 40 total apples, so 40 times 1/8 is 5 apples. The second group ate 4 of them. That's easy. It told us how many they ate. We didn't have to calculate anything. And the third group ate 20% of them. So 20% of 40 is 8 apples. So that means they ate a total of 5 plus 4, which is 9, plus 8. They ate a total of 17 apples. So to see how many apples were left over, we started with 40, 17 got eaten, leaving us with 23 apples left over. Number 4, how much greater is the circumference of the larger circle? So we have 2 circles here. The circle on the inside, the smaller circle, I labeled circle 1, has a radius of 4.5 and a diameter of 9. I know to find the circumference, it's c equals pi times diameter, so c equals pi times 9. The larger circle has a radius of 11.5, which means it has a diameter of 23. So to find that circumference, we do c equals pi times 23, which is the diameter. Now, because you're not at school, the blue calculators we use in school have a pi button. However, any calculator, even one on your phone, has a decimal. So if your calculator does not have a pi button, for the rest of this week, use 3.14 as pi. So to find the circumference of the first circle, you do 3.14 times 9. To find the circumference of the second circle, you do 3.14 times 23. Okay, the LEQ we're going to be focusing on this week is what are the parts of a circle and how can they be used to solve problems. The activator for today says what is the difference in the area between the larger and smaller circles? Go ahead and pause it and figure it out now. Okay, circle 1, which I'm labeling the smaller circle, clearly has a radius of 5, which means it has a diameter of 10. If I need to find the difference between the areas, I need to use the formula A equals pi r squared. In this case, the radius, or r, is 5. So I'll do 3.14 times 5 to the second power. And that gives me an area of 78.5 for the first circle. Now, the second circle is a little bit trickier to figure out. I'm guessing that many people are going to say that 6 represents the radius of this larger circle. However, that larger circle, the center, is actually right here. So really, we know this radius is 5. The radius of the larger circle is here to here is 6, here to the center is 5. So the radius of the larger circle is actually 11, making the diameter of the larger circle 22. To find the area of this larger circle, we do area equals pi r squared, and we know that the r in this case, the radius is 11. So Pi, 3.14 times 11 squared gives us 379.94. And when we subtract those two, we find the difference is 301.44. All right, if that was challenging for you, we're going to take circles back to basics a little bit. So when you look at that circle in front of you, the first thing you should do is draw it out. Once you have it drawn out, you can use the information that's given to figure out anything else from the circle you want. So take the next couple minutes and figure out anything you think you can based on the circle you're given. Okay, because of that one piece of information they gave us in this circle, that the radius was 6.5, we can figure everything else out. Because if the radius is 6.5, that means the diameter is 13. So to find the circumference equals pi times diameter. So 3.14 is pi times 13 as the diameter, gives us a circumference of 40.82. We also can figure out the area. Area is pi times radius squared. So if the radius is 6.5, we would type in 3.14, which is pi, times 6.5 to the second power, and find that it has an area of 132.66. Basically, with circles, if you are given any single piece of information, the radius, the diameter, the circumference, you can use that one piece to unlock everything else from the circle. So we're going to look at a couple problem-solving problems together, and then you could try the work on your own. It says, an artist is designing new plates for a home and garden show. She is only going to paint the area that is not gray. What is the total area she's going to paint? So when I take a look at this, I see two circles. I see the larger circle, which is on the outside, and then I see that gray circle on the inside. When I'm thinking about the larger circle, I see that 11 goes all the way across. So that must be the diameter. In my inside gray circle, I see it has a radius of 4 in that small circle. So the first thing I'm going to think about is getting the information from my two circles. So the circle in green, the information in green, represents the large outside plate, a diameter of 11, a radius of 5.5. And then I wrote the area formula because we're talking about area. The small inside circle, I wrote the radius is 4, which means the diameter is 8, and I wrote that formula. So what we can do then is calculate the area of both the larger circle and the smaller circle. So the larger circle, 3.14 times 5.5 to the second power, has an area of 94.98. The smaller circle, 3.14 times 4 to the second power, has an area of 50.24. So 94 is the area of the entire thing if everything was shaded in. The smaller circle has an area of 50.24. So to find the area that is not gray, we'll take the total area of the plate, which is 94.985, and subtract the area on the inside, which is 50.24, and see that 44.74 square inches will be painted not gray. In this problem, it says a painter needs to cover the diagram below with blue paint. What is the total area of the figure? When I look at this ice cream cone shaped thing, the first thing I notice is I see two shapes there. I see a triangle. And when I'm talking about covering it, I know that's area. And I know that to find the area of a triangle, I can use the formula 1/2 times base times height. I also see a semicircle or half circle there, which means I can use pi times radius to the second power. However, since I notice it's only a semicircle or a half circle, I'm going to make a note to myself that really I just want half of that area. So now, using my information, I can just calculate both areas and combine them together. So this has a diameter of 12 because it stretches all the way across, which means it has a radius of 6. So the area will be pi times 6 to the second power. So I can do 3.14 times 6 to the second power, and find an area of 113.04. But I know that that 113 would be the area of an entire circle. I only have half of a circle here. So I'm going to take that 113.04 and I'm going to divide it in half, which means I have an area of 56.52 for the circular portion. So this has an area of 56.25. I'm sorry, 52. But I also have to find the area of my triangular piece. The area of a triangle is 1/2 times base times height. So I can do 1/2. And looking at this here, I have a base and a height that's given to me. The base of this triangle right here is the same as the diameter. So 1/2 times 12, and you can see that the height of it is 4. 1/2 times 12 times 4, which is 24. So my triangular piece has an area of 24. My semicircle has an area of 56.25. So to find the total area, I add those together and see that the total area is 80.52 square feet. One additional problem before we get to the classwork is just a quick review on working backwards. It says to surround a hat, a piece of string that is 84 inches is used. What is the approximate diameter of the hat? What is the approximate radius? Well, I know if I'm talking about radius and diameter, we're talking about circles. And in this case, they actually don't tell us the radius or the diameter. What they do tell us is kind of hidden. They say to surround a hat, a piece of string 84 inches is used. Well, I know when I'm talking about surrounding, that's circumference. So I know that the circumference is 84 inches. So when we're doing this problem solving, it doesn't help us to say we don't know things, like I don't know how to do this or I don't get it. Let's think about what we do know. Well, we do know that to find the circumference of a circle, its circumference equals pi times diameter. We also happen to know the circumference, which is 84. So 84 equals pi times diameter. This is just a one-step equation here. We can take this single piece of information and use it to answer anything. So to find the diameter, we just divide each side by pi. It's a one-step equation. That way, we're going to know what the diameter is. 84 divided by 3.14 gives us a diameter of roughly 27. Your calculator will probably say 26.751 with a long string of decimals. So now, if we know the diameter is 27, the radius is half of that, so 27 divided by 2, we're going to have a radius of around 13. So from this one piece of information, we were able to work backwards to figure out the diameter and the radius of this circle. Okay, here's your classwork for today.